How we doing, guys? Looking today at geometric series, which is where you add the numbers together, okay? But you can see each term here makes up a geometric sequence. So in this first one, your first term will be 2, so that's a equals 2. And your common ratio is you go 2, 6, 18. You're multiplying by 3 with each step. The question says find the sum of the first 10 terms in the series. So we'll turn to our log tables, page 22, and we'll look at this formula for the sum of a geometric series. We'll just use the formula once or twice before we see where it comes from. So question 1 there. Question 1 says 2, 6, 18, 24. A, our first term is 2, and our common ratio, you're multiplying by 3 with each step. So R equals 3. We're going to use this formula from the log tables. Sn is 8 times to find the sum of the first 10 terms is what they've asked us for. So that's S10 equals A is 2 times 1 minus the common ratio to the power of n, in this case is 10, divided by 1 minus that common ratio, 3. Okay, so that's 2, that's minus 2 on the bottom, and 1 minus 3 to the power of 10 is 1 minus 3 to the power of 10 equals minus 59048. So the 2's cancel, minuses cancel, we're left with 59048. That's the sum of the first 10 terms. Okay, question 2 says find the number of terms in the following series, and then hence find the sum of the series. So the first term, find the number of terms. We're going to go back to our old formula that we've seen before for the number of terms in a geometric sequence. Okay, and we're going to say, well, to work out where does 32 lie in this sequence, we'll say A is 1024, and our common ratio, well, you're multiplying by 1/2 with each step. Okay, so that's multiplied by 1/2. So 32, well, where does that fall? If Tn is AR to the n minus 1, for us, Tn is 1024 times 1/2 to the power of n minus 1. And our nth term is 32. So we need to solve this problem, okay, which is going to use a little bit of logarithms in a second. Dividing through by 1024, you're going to say 32 divided by 1024 gives 1 over 32. So that's 1 over 32 equals 1/2 to the power of n minus 1. Okay, how do we go about doing this? I suppose I'm going to use my usual if 2 cubed is 8 and log base 2 of 8 equals 3. So I'm going to rearrange it. So 2 cubed equals 8. I want to get the 3 by itself. So what are we looking at here? We're saying log base 1/2 of 1 over 32 is n minus 1. Okay, that's how you rejig this. You can do it using indices as well, but I think this way is probably more widely applicable. Okay, you go to your calculator, you're going to get 5 for that. So n equals, it's the 6th term. By the way, I know you could do this by counting as well, but that only works when n is some low number like 6. It won't work when n is 600. The next part of that question then was asking you to find the sum of the series. So that's S6. Okay, so we're going back to our formula that we saw at the start of the video. S6, that is A times 1 minus R to the n over 1 minus R. And we're saying A is 1024 times 1 minus 1/2 to the power of 6 divided by 1 minus 1/2. Okay, by the way, this formula is going to come up an awful lot in financial maths. So do get familiarize yourself with it. Oh, excuse me. Familiarize yourself with it and make sure you're comfortable with it. 1 minus 1/2 to the power of 6 is giving 0.984375, which I'm sure is some fraction. Multiplied by 1024, and you get 1008. Divide by 1/2, and you get 2016. Okay, So that's question 2. Okay, question 7, 8, 9. You can see we're back to using this sigma notation. I'm going to jump in maybe with question 8. Okay, we're going to evaluate that. Question 10 and 11, we'll discuss them in class, I think. So I'll finish up with question 8. Okay, so you're asked to evaluate this. Well, the sum of 2 times 3 to the r for values of r between 1 and 8 is going to be 2 times 3 to the 1 plus 2 times 3 to the 2 plus 2 times 3 to the 8. Okay, and what you're going to get here is 2 times 3, that's 6, plus 2 times 9 is 18, plus 2 times 3 cubed. Well, you're multiplying by 3 with each step, aren't you? You're increasing the power by 1. So you're multiplying by 3. So 3 times 18 is going to be 30, and 24 is 54, plus 2 times 3 to the 8, 2 times 3 to the power of 8 is going to be 13122. Okay, but the big thing you want to spot is that there's 1, 2, 3, 4, 5, 6, 7. There are 8 terms. Our first term is 6 and our common ratio is 3. So the question is find the sum of those 8 terms. That's what this means, the sum of, and it's a list of 8 numbers, okay, all of which have this form. So that's just using our a times 1 minus r to the n divided by 1 minus r, which I just realized I never showed you where that came from. A is 8, oh sorry, a is 6 times 1 minus 3 to the power of 6, all divided by 1 minus 3. Okay, so that's 6 times 1 minus 3 to the power of 6 gives that, multiplied by 6 equals that, and then divided by -2. Okay, we get 2184. Okay, so that's question 8 done there. I might make a separate short video showing where the formula comes from. Can I ask you now, please, for homework, or well, for now work, please. So right now, if you could do, excuse me, page 352, questions 3 and question 6. And I think tomorrow we'll probably finish that exercise. Okay, don't forget to watch that second video about where we've gotten this formula from here. Okay, right, bye-bye. No, excuse me. I just spotted that should have been an 8, shouldn't it? That's awful embarrassing. So that answer is wrong. Maybe you can do that piece of work yourselves before you do question 3 and question 6. Okay, bye-bye.